Hello and welcome to Lesson 7 of the Big Data and Hadoop Developer course offered by Simplilearn. This lesson will focus on Pig. Let us explore the objectives of this lesson in the next screen. By the end of this lesson, you will be able to explain the concepts of Pig, demonstrate the installation of a Pig engine, explain the prerequisites for preparing the environment for Pig Latin. In the next screen, we will discuss the challenges of MapReduce development using Java. Some of the common challenges faced while preparing a program on MapReduce using Java are as follows. A developer must be able to think in terms of map, split, and reduce fundamentals while creating a Java program. Due to this, a developer's production time may get impacted. The second challenge is the need for common operations like joining, filtering, projecting, and splitting, which require writing custom codes in Java. This requires more time and concentration. Further, MapReduce enforces a rigid data flow. It is difficult to deliver the output of a task as the input of another. As the operations grow more complex, the code is usually difficult to maintain, optimize, and extend. In the next screen, we will understand Pig. Pig is one of the components of the Hadoop ecosystem. It is a high-level data flow scripting language. Pig runs on Hadoop clusters. It was initially developed by Facebook for their project as they did not want to use Java for performing Hadoop operations. Later, Pig became an Apache open-source project. Pig uses HDFS for storing and retrieving data, and Hadoop MapReduce for processing big data. In the next screen, we will learn about the basic components of Pig. The two major components of Pig are the Pig Latin script language and a runtime engine. The Pig Latin script language is a procedural data flow language. It contains syntax and commands that can be applied to implement business logic. Examples of Pig Latin are load, store, etc. The runtime engine is a compiler that produces sequences of MapReduce programs. It uses HDFS for storing and retrieving data. It is also used to interact with the Hadoop system, that is HDFS and MapReduce. It parses, validates, and compiles the script operations into a sequence of MapReduce jobs. In the next screen, we will understand how Pig works. Pig's operation can be explained in three stages. In the first stage, the data is loaded and a Pig script is written. In the second stage, the Pig execution engine parses and checks the script. If it passes through, the script is optimized, and a logical and physical plan is generated for execution. The job is submitted to Hadoop as a job comprising map and reduce tasks. Pig monitors the status of jobs using Hadoop API and reports the status to its client. In the execution stage, the results are dumped on the screen or are stored in HDFS depending on the user command. In the next screen, let us understand Pig's data model. As part of its data model, Pig supports four basic types. The first is atom, which is a simple atomic value like int, long, double, or string. The second is tuple, which is a sequence of fields that can be of any data type. The third is bag, which is a collection of tuples of potentially varying structures and can contain duplicates. And finally, there is map, which is an associative array. The key must be a char array, but the value can be of any type. In the next screen, we will continue the discussion on data model. By default, Pig treats undeclared fields as byte arrays, which is a collection of uninterpreted bytes. Pig can infer a field's type based on the use of operators that expect a certain type of field, UFDs or user-defined functions with a known or explicitly set return type, and schema information provided by a load function or explicitly declared using an AS clause. Please note that type conversion is lazy, which means the data type is enforced at the point of execution only. In the next screen, let us understand a nested data model. By default, Pig treats undeclared fields as byte arrays, which is a collection of uninterpreted bytes. Pig can infer a field's type based on the use of operators that expect a certain type of field, UFDs or user-defined functions with a known or explicitly set return type, and schema information provided by a load function or explicitly declared using an AS clause. Please note that type conversion is lazy, which means the data type is enforced at the point of execution only. In the next screen, let us understand a nested data model. Pig Latin has a fully nestable data model with atomic values, tuples, bags or lists, and maps. This implies you can nest one data type within another as shown in the image. The advantage is that it is more natural to programmers than flat tuples. Also, it avoids expensive joins. In the next screen, let us understand Pig execution modes. Pig works in two execution modes, namely local mode and MapReduce mode. In local mode, the Pig engine takes input from the Linux file system and the outputs is stored in the same file system. In MapReduce mode, the Pig engine directly interacts and executes in HDFS and MapReduce. In the next screen, we will discuss Pig interactive modes. The two modes in which a Pig Latin program can be written are the interactive mode and batch mode. Interactive mode means coding and executing the script line by line as shown in the image. In batch mode, all scripts are coded in a file with the extension .pig as shown in the image, and the file is directly executed. In the next screen, we will understand the salient features of Pig. Pig offers us many features which make it quite attractive to developers and analysts. Some of the features are as follows. It provides step-by-step procedural control and the provision to operate directly over files. Pig has schemas that, though optional, can be assigned dynamically. It also supports user-defined functions or UDFs and various data types. In the next screen, we will differentiate between Pig and SQL. The first difference between Pig and SQL is that Pig is a scripting language used to interact with HDFS, while SQL is a query language used to interact with databases residing in the database engine. In terms of query style, Pig offers a step-by-step execution style compared to the single-block execution style of SQL. Pig does a lazy evaluation, which means that data is processed only when the store or dump command is encountered. However, SQL offers immediate evaluation of a query. Pipeline splits are supported in Pig, but in SQL, you may require the join to be run twice or materialized as an intermediate result. In the next screen, we will look at an example to illustrate the difference between Pig and SQL. Let us look at an example to understand the SQL command and its Pig equivalent command script. The SQL command focuses on the customer table having column C_ID and C total, which is the sum of amount. It joins sales table with reference to C_ID, where C.city is Texas. The grouping of C_ID is performed by having the sum of the amount greater than 2,000 ordered in descending order. Let us see how the same function is carried out in Pig. In Pig, you create two entities, customer and sales, where you load equivalent data with the schema. You filter the customer based on the city as Texas. Both data are joined together using the C_ID row. The sum of the amount of individual C_ID is calculated. Separate those customers who spend more than $2,000. Later, we sort the customers in descending order. In the next screen, let us install Pig. To install the Pig engine, you need to get the correct mirror web link from the URL mentioned on screen. Use the command as shown on the screen to download the Pig 0.13.0 tar file and store it in the server system using wget command. In the next screen, we will explore the steps to install Pig. You need to perform the following steps to install the Pig engine. Unzip the downloaded file. Move the extracted folder to /usr/local/pig. Export Java_home path. Export pig_prefix path. Set the path for the bin folder of Pig setup. In the subsequent screens, we will examine each step in detail. Unzip the downloaded tar file using the command shown on screen. Please check if the file name matches with the one you have downloaded. In the next screen, we will learn the process for moving the extracted folder. Once extracted, move the folder to /usr/local/pig. This can be achieved using the command shown on screen. Make a note of the file name. Sometimes the file name changes after extraction, so check the file name by using the ls command and then perform the sudo mvpig command. In the next screen, we will export Java_home. There are multiple ways to export Java_home. One method is to execute the export command directly, as shown in the image. Ensure that the Java path provided is correct and verified in your system. In the next screen, we will export the pig_prefix path. Use the command shown on screen to export Pig. In the next screen, we will set the path for Pig. Use the command shown on the screen to set the path. In the next screen, we will learn the steps to run a sample program. Run a sample program to test Pig. Start writing the program once you upload the data in the Hadoop server that is running in pseudo-distributed mode, also referred as single-node server. Run Pig in local mode using the command shown on screen. Check whether the file is accessible through the grunt shell using the command shown on screen. Load data in Pig and generate the output as shown on screen. In the next screen, we look at some big data sources. You can get books, download the Wikipedia database, and variant data sets from the URLs listed in the table. You can also get Open Database from Amazon S3 and National Climate Data Center. In the next screen, we will look into the steps to get the environment ready for Pig Latin. Ensure the following parameters while setting the environment for Pig Latin. Ensure all Hadoop services are running, Pig is installed and properly configured, and all datasets are uploaded in the name node, that is HDFS. In the next screen, we will examine each step discussed here. Ensure all Hadoop single-node or pseudo-distributed mode or multi-node cluster services are running. This can be done by typing JPS in the command console. In the next screen, we will check the Pig status. Ensure the Pig engine is completely installed and configured by running Pig in MapReduce mode. In the next screen, we will ensure the data sets are uploaded. Ensure the required datasets are uploaded in HDFS using the command shown on screen. In the next screen, we will see some of the methods implemented in Pig Latin. Loading refers to loading relations from the files in the Pig buffer. The image shows the command for loading data in the Pig engine. This is done by using the load keyword. A load statement reads data from the file system. A series of transformation statements process the data. A store statement writes output to the file system, or a dump statement displays output to the screen. In the next screen, we will see the usage of the store keyword. Store a complete book from the Pig engine to HDFS. This is done using the command store followed by the name of the variable whose data is to be stored and the location of storage. You can also verify the contents from the web GUI as shown in the screenshot. In the next screen, we will learn about the Pig execution plan. Pig processes Pig Latin statements in the following manner. First, Pig validates the syntax and semantics of all statements. Then, it type checks with schema. Later, it verifies references. Pig performs limited optimization before execution. Next, if Pig encounters a dump or store, Pig will execute the statements. Store operator will store it in a file. A Pig Latin script execution plan consists of the logical plan, optimized logical plan, physical plan, and MapReduce plan. In the next screen, we will learn about filtering and transforming. Filtering can be defined as filtering of data based on a conditional clause. An example for filtering is shown in the image where the results are filtered based on grade. Transforming refers to making data presentable for extracting logical data. An example for the same is shown in the image in which a book is transformed into a number of words. In the next screen, we will learn about grouping and sorting. Grouping refers to generating a group of meaningful data. An example for the same is shown in the image. Sorting of data refers to arranging the data in either ascending or descending order. This is shown in the image. In the next screen, we will discuss combining and splitting. Combining refers to performing a union operation of the data stored in the variable. An example is shown in the image. Splitting refers to separating the data with a logical meaning. An example of this is shown in the image. In the next screen, we will look at common Pig commands. Some of the common Pig commands are as follows. Load reads data from file system. Store writes data to file system. For each applies expression to each record and outputs one or more records. Filter applies predicate and removes records that do not return true. Group and co-group collect records with the same key from one or more inputs. Join joins two or more inputs based on a key. Order sorts records based on a key. Distinct removes duplicate records. Union merges two data sets. Split splits data into two or more sets based on filter conditions. Stream sends all records through a user-provided binary. Dump writes output to std out. Limit limits the number of records. In the next screen, we will explore a business scenario followed by demos. Olivia is the EVP of IT Operations with Nutra Worldwide Incorporated. Tim Burnett, the AVP of IT Infra Ops, is assigned to one of her projects. Olivia has assigned Tim the task of analyzing huge volumes of data pertaining to a research study. He has decided to use Pig given the efficiencies he can derive from it. At the same time, he notices that the company does not have a Pig engine in place. The demos in the subsequent screens illustrate how to install a Pig environment for a large corporation and how to perform analytics using the same. In addition, they also illustrate how to write Pig scripts using different scenarios. In the subsequent screens, we will watch the related demos. In this demo, we will see how to install Pig in Ubuntu 12.04 Server LTS. Visit the website www.pig.apache.org. Click the project link. Click the Releases link. Scroll down and under Download, click Pig 0.8 or the given link as you are intending to download Pig version 0.11.1. Select a mirror link to download Pig. Select Pig-0.11.1 folder. Right-click the tar file and copy the link location to get the link location and use it in Ubuntu Server to download the package. Type wget and paste the link copied in the web page. Once the download is completed, untar the file, downloading using the command shown on the screen. Press Enter key. Copy the extracted folder in the location /usr/local/Hadoop. The next step is to set up bash rc to include pig prefix and to set the path. Press Enter key. Set pig_prefix. Press Enter key. Set the path for pig. Press Enter key. Refresh the bash by typing exec bash. To check whether pig is successfully configured, type pig-x local. Press Enter key. If it shows the grunt prompt, it means the pig is installed and configured successfully in the node. You have successfully installed and configured pig. Let us do a quick recap of the steps performed. In this demo, we will find out how to write a pig script to convert any lines of unstructured data into their equivalent words in local and MapReduce modes. Ensure that you have your sample data in the system. Here, the sample data file name is testdata.txt. Initially, we will run this program in MapReduce mode. For that, it is necessary to upload the data in HDFS. This can be done using the command shown on the screen. Then press Enter key. To start pig in MapReduce mode, the command used is pig. Type pig and press Enter key. Since we need to specify the location of the data in the program, ensure that your data is on the location. Type the command shown on the screen. The first line of code is responsible to load the data from HDFS to temporary pig storage for processing the same. The keyword load is responsible to pick the data from the specified location. Pig storage is the temporary data location, like a cache, which will be used during the processing period. We will be using variable named lines with a character array data. Type, that is, char array. Ensure that you add a semicolon at the end of the statement. Type the command shown on the screen. Press Enter key. The next line will convert lines into words. This is done using a looping statement. That is, for each which will generate words by flattening the lines, which means removing all characters other than 0 to 9, A to Z, and A to Z. Tokenize will ensure that each word will be a separate entity which will be stored in an array as a word. Type the command shown on the screen. Press Enter key. We will list the output using the keyword dump. We will see the words generated which are stored in variable words. Type dump words. Press Enter key. The highlighted part shows the output that is generated and stored in the variable words. Let us try the same program in the local mode. Start Pig in local mode using the command pig-xlocal and press Enter key. Type the same line to load the data with a difference that the data is loaded from ext file system and not from HDFS. Type the command shown on screen. Press Enter key. The next line will convert lines into words. This is done using a looping statement, that is, for each will generate words by flattening the lines, which means removing all characters other than 0 to 9, A to Z, and A to Z. Tokenize will ensure that each word will be a separate entity which will be stored in array as word. Type the command shown on the screen. Press Enter key. We will list the output using the keyword dump. Type dump words semicolon. Press Enter key. We will see the words generated which are stored in variable words. The highlighted part shows the output of the program. If you observe, it states that the program is run in local mode using local resources. You have successfully implemented the program for separating words from lines. Let us do a quick recap of the steps performed. In this demo, we will see how to write a pig script for loading the files into relations. Let us look at loading a file in pig relations. First, let us create a sample dataset called login.txt. Date, timestamp. Each record is present in a new line and different data elements are separated by a comma. Save and exit. Use the cat command to view the file contents. Copy the file to HDFS. In this case, we will copy it to the learning directory. Launch Pig. If Pig is already installed properly, enter Pig on command prompt. You will see Grunt on the screen. Pig's command line interface is Grunt. Load login.txt in user login relation with user and date timestamp separated by a comma. Specify user as char array data type and date timestamp as long. Notice the usage of handler pig storage along with which you specify comma delimiter. Dump user login on screen to verify whether the loading is successful. Dump and store in pig initiate MapReduce job, firing off as lazy execution a series of steps covered in the pig script preceding dump or store. Once the MapReduce job is complete, the output is shown on the screen. Let us do a quick recap of the steps performed. In this demo, we will see how to perform pig scripting for performing data analytics of a book to find the number of occurrences of the word "the" throughout the book. Start pig in MapReduce mode. Load testdata.txt using the command file equals. Type the command to load testdata.txt file. Press Enter key. To convert the lines into words, use the command shown on the screen. Press Enter key. Create a group of words. Type the command shown on the screen and press Enter key. Let us aggregate and count the words. The command used is shown on the screen. Press Enter key. Dump the output in the screen. Type the command given on the screen and press Enter key. You can see the output of the program in the highlighted part. It shows each word with the number of occurrences. Let us try the same program in the local mode. Start pig in the local mode. Load testdata.txt using the command shown on the screen. Press Enter key. Convert the lines to words. Type the command shown on the screen and press Enter key. You have to create a group of words. Type the command shown on screen and press Enter key. Let us aggregate and count the words. The command is shown on the screen. Press Enter key. Dump the output in the screen. The command is shown on screen. Press Enter key. You can see the output of the program in the highlighted part. It shows each word with the number of occurrences. You have successfully executed the program. Let us do a quick recap of the steps performed. In this demo, we will see how to write a pig script to perform combining, splitting, and joining relations. Load the January data. type the command shown on the screen and press Enter key. Load the February data, type the command shown on the screen and press Enter key. Load the March data, type the command shown on the screen and press Enter key. Load April data, type the command given on the screen and press Enter key. Let us perform combine operation in which we will combine the data of all 4 months. Type the command shown on the screen and press Enter key. Let us see the result of combining the data. Press Enter key. Execution is done successfully. Check for success line. Let us see the output. Go to Name Node GUI. The address is http://192.168.201.153:50070. Click the Browse the File System link. Click the Data link. Click the Big link. Click the Pig Results link. Click month_quad file. The output is displayed. Let us perform splitting operation. Type the command shown on the screen and press the Enter key. Let us see the output of the split. Type the command given on the screen and press Enter key. The program will execute successfully. Let us check the output for split. Go to Name Node GUI. The address is http://192.168.201.153:50070. Click the Browse the File System link. Click the Data link. Click the Big link. Click the Pig Results for link. Click the Jan link. The list shows the output for the same. You have successfully performed the program. Let us do a quick recap of the steps performed. In this demo, we will learn how to write a pig script to perform transforming and shaping of the relations. Let us first understand the program flow. The highlighted lines are responsible for loading the data for months January, February, March, and April. The highlighted line is responsible for performing the union operation of the months. The highlighted line is responsible for performing the splitting operation of aggregated data. This line performs filtering of data based on clear sky parameter. This line stores the output of the transformed table. Let us execute this program in batch mode. Type the command shown on the screen. The program execution starts. Since the data is 2 gigabytes, it will take around 15 minutes to perform execution of the same. Name node GUI using the address http://192.168.2.1.153:5007. Click the data link. Click the big link. Click the Pig Results 5 link. Click the Shaped link. The output is generated successfully. Click any one file to view the output. Thus, we have performed the program successfully. Let us do a quick recap of the steps performed. Let us summarize the topics covered in this lesson. Pig is a high-level data flow scripting language and has two major components, Runtime Engine and Pig Latin language. Pig runs in two execution modes, local mode and MapReduce mode. Pig script can be written in two modes, interactive mode and batch mode. Pig Engine can be installed by downloading a mirror web link from the website pig.apache.org. The environment for Pig Latin is set in 3 steps. In the next lesson, we will discuss Hive.